Bam. Hey, how's it going?
Hey everybody, extraktLAB here coming at you. We're going to talk a little bit about sustainability and the best way that you can help the environment by choosing your extraction method. Most people tend to focus on growing and packaging as their main thing. We're going to be talking about production, which is another big part.
Well, a lot of people have been looking at, their operations, Jared, and they kind of, they look at it and they say, okay, is it sustainable? I got all those lights burning, so people are going to LED, right? So they don't have a lot of lights.
Absolutely.
Some people are, for example, reusing CO2. They use reused CO2 so that instead of burning propane, which is kind of not as good, but a lot of people do that, right?
Sometimes you gotta do what you gotta do to make it happen. But that's the big thing, and I think that's what we're doing is getting people to kind of look at how they're operating again, whether it's through growing or processing. But people really need to start paying attention to this. This is our only planet. We only got one of them, so we want to treat it well.
Right. So what we've been doing is kind of looking at sustainability. We've done a couple talks on that so far, a couple podcasts. It's been pretty good. We've put out some, additional resources, but as we start to get into this more and more, I keep on adding to, the talk, and I got some calculators and I got you're making some quizzes. Just kind of putting stuff together. So
I'm trying to keep them light for everybody. As we start getting more people taking them, we'll definitely hit them with them hard questions.
But it's kind of fun. Quizzing is kind of cool because people get to interact with the content, try to test their knowledge and things like that.
Absolutely.
It's a great time. So.
Yeah, definitely.
What I got here on my screen, let's take one of those quizzes, man, that you made up. It's pretty sweet. Here's a quiz. So we'll look at that. One of the things that we've really been looking at is using some ISO methodology to go back into the extraction and processing operations and really just take a look at it. Is it green or not, right? How green is it?
Absolutely.
And how much of a carbon footprint it is. Sustainability has been a really big topic. I've been invited now several times to go talk at different places. Got an invitation from the Georgia State Legislature.
Really? Nice.
So that's pretty cool.
Awesome.
I mean, people are really starting to look at this, and in our industry, we do tend to go after the latest and greatest things. I think that's because we're born innovators.
Absolutely, definitely.
All of us are, in the whole industry. And so we're kind of looking for the new thing, all the time. But oftentimes, it doesn't mean that if there's a new thing that that necessarily is the best thing, right?
Right, exactly. Yeah, a lot of people are just trying to, like you said, chase the next big thing. In my opinion, I think sustainability, it has been a big thing in this industry for a long time. I think we're starting to take a harder look at it as the industry is starting to establish itself more. You don't want to be seen as that guy, you're just dumping your nutrients or your waste into the river or putting your biomass outside your facility and just letting it dissipate into the air, because then you're putting VOCs in there. And people might not have thought about that before, but...
right, exactly. So we went through different types of operations and calculated the amount of CO2 that we converted everything to a CO2 footprint. So that was pretty cool.
Right.
And then we got this amazing result. It blew me away. I couldn't believe it when I actually looked at it. So we're going to kind of go through that. First of all, we'll go through this quiz and see. So the first one, what's the greenest extraction solvent?
Right.
Well, a lot of people would say ethanol because CO2 is okay, that's not thought of as green, right?
You hear CO2 and it's oh man, they're ruining the environment.
Okay, so we're going to choose ethanol here. Okay. And then is there a difference in greenhouse gas, which means GHG, greenhouse gas that's produced while manufacturing based on which method is used? Does that question make sense? I think it does.
A little bit. I think it's just basically asking how much gas is produced depending on the method. Again, you think CO2 is probably going to be the number one. So,
I don't know. I don't know. Is there a difference? I don't think there's a difference. Okay.
All right. Yeah. Let's see. Let's see
what happens. Okay. How many pounds of greenhouse gas do most vape, tincture, or extracts take to make? Okay. Wait. Let me get my head around this.
Getting a little technical.
So now
here.
I have a vapor pen, or I have some tincture. And I want to know how much CO2 it costs the environment to produce that tincture, that 1 gram.
1 gram, one little tiny gram.
Oh, okay. It's Okay. Well,
So you wouldn't think it's not going to be that much.
no, it can't
I mean,
be,
I would
it
think
can't be
less
that
than a
much.
pound.
Less than a pound. Oh, oh, look at that pesky. It's asking me. It's asking me for my email. We're going to send it. All right.
Well, yep,
So,
send it.
do you care about the earth? Yeah, absolutely. Oh, what's this?
No, no.
Result zero.
Zero.
Oh, no.
Yep, yep.
You mean
so,
I got it all wrong?
yes,
Oh,
yes.
That's terrible.
And that's okay. There's still room for
Okay.
improvement.
All right.
There's always
so,
room for improvement.
Hey, we should put a little picture of me there smiling.
Oh, there we go. Yeah, yeah. Or we should give the, discouraging
smelling-
finger because these ones that, obviously didn't do so well on this test.
Maybe me smelling some hemp flowers or something.
We could do that. We could do that. We'll
All
put
right.
something great.
All
in
right.
there.
Anyway, so let's get into the presentation and really kind of get down to the answer. What is the answer? I'm going to kind of scroll here to the answer, and I'm going to put that on
man.
here. This is going to blow you guys away. Oh my gosh, it's going to blow you away. Okay, so here's the answer.
For every 1 gram tincture or vapor pen containing an ethanol extracted oil, so produced using ethanol, 95 pounds of CO2 was emitted, which is wow. 1 gram. Again,
gram.
one little vapor pen takes 95 pounds of CO2 to produce that. I think that all kind of goes into producing the ethanol, growing the corn, moving it, modifying it, and then bringing it to where it needs to be. And then we're
Yep.
also talking about the
Cooling and heating.
Yes,
and
yes, there's a
all
lot
that
to
stuff. And then one of the things that we have talked about a lot on this show is just the energetics of cooling and heating. If you guys
Yeah.
haven't seen that, we talk a lot about that in several of our earlier podcasts, and
Yep.
we have calculators, in fact, that will allow you to kind of calculate that. But when you heat, say you take ethanol and then you heat it up to boiling point, and then you evaporate it, this thing called the heat evaporization.
Yep.
And it takes a lot of energy to get there, and so
Yeah.
that's where all the kilowatts are going.
Right.
And then you're going from that vapor, you're condensing it down all the way down to what, minus 20, minus 40?
Yep, minus
right?
40. Yeah.
Wow. So you have a huge temperature differential, 25 degrees to minus 40 degrees Celsius. And so that's just taking a tremendous amount of kilowatts of energy.
Absolutely.
And, CO2 doesn't do that. So, so that's one thing. And then the other thing is that the ethanol itself, you got basically 131,000 BTUs to produce 1 gallon of ethanol.
Yep. Wow. Right. Exactly.
So that came from Cornell Law or Cornell Review, by the way. So
All
it's
right.
it's a very good scientific measure there. So
Yeah, yeah.
if you have a solvent intensive process of any kind at
Yep.
all, you really are going to be paying the price with, hey, look, this is how much CO2 it costs me to actually use this stuff.
Right. You're not just buying the ethanol, you're buying everything that it took to produce that ethanol.
Right.
And then again, what you're going to have to do to it once you actually start using it. So
Right,
there's a
exactly.
lot more to it than people think about.
Yeah, I think it's kind of something you got to get your head around it. Okay, so I got the ethanol. I'm going to use the ethanol, and but that ethanol it's actually costing you carbon. Okay.
Yep.
And
Yep.
and so the other thing would be, okay, now I got my ethanol, and now I'm going to extract it, right? And
Yep.
the thing about the ethanol is it doesn't really all come out 100%
No.
out of it. So so there's maybe anywhere from 5 to 0 to 5% left in. Okay,
Yeah.
very rarely do you get 0. But what happens is the ethanol gets entrained into the biomass.
Yep.
It's entrained in there, and even though it's experiencing a tremendous amount of G forces from the centrifuge that they put them in,
Yep.
it's not 100%. Nothing's 100%.
No. Just
In the whole entire world, there's nothing that's 100%.
yeah, look at your clothes
Except for
with
me, I've gone 100% all the way on this.
Yep, go
No,
hard.
No, but I just, in terms of recovery processes or anything like that, or there's always what they say, you just kind of not get in there all, it takes you a long time. to get there.
acceptable loss
Yeah,
is what
exactly.
they
Yeah.
consider it. And
So they're looking at 95%. Now, if you have 95%, that means that 5% is left in the biomass. Let's just say that, okay?
Right.
If some people would say, oh, I get 97%. Okay, whatever. Okay,
All
so
right,
3%,
all right.
I don't care.
Yeah.
But whatever that is, when you put that outside, it's going to go off into the atmosphere
Yep.
eventually.
Yep, and that's where the problem is.
Yeah.
Again, there's no way we're spending all this energy creating the ethanol, and then we're putting it right back into the atmosphere.
as VOC.
Right, and it's not in a good way.
No, because
Not in a good way
that
at all.
actually comes off, and ethanol is a known ozone promoter.
Yep.
So for those people, that's why it's called volatile organic carbon, and typically you have to have a permit for that.
Yep.
So that's something that you need to think about, when you're in your different areas is, okay, what's the permit for my VOC? It's not considered a hazardous air pollutant. However, I don't, at least I don't remember ever seeing ethanol on the list of HAP, what they call HAP hazards.
Okay.
But yeah, I don't know. If someone has any information on that, give us a call.
Definitely.
Chime in and see what that is. So now, in juxtaposition to that, so we got the VOC, we got the heating and cooling,
Yep.
we got the ethanol itself, we got the losses of the ethanol to VOC.
Yep.
Am I missing anything else? I think that those are the main ones.
I think those are the biggest.
Yeah. So
biggest factors.
and if you take all those losses and you put them together, oh yeah, I remember. One thing also is that like people who do solvent extraction processes in other industries for other botanicals they do them, like soy, for example.
Oh, yeah.
They use hexane or they use ethanol or whatever. You really can't get an organic unless you use organic ethanol, right? Okay, there's no such thing as organic hexane. Okay, so you're really dealing with those processes there. But the thing about that is, first of all, if you look up sustainable chemical practices put out by Wiley, okay, these are like scientists who've written a lot. I mean, they just go through all the issues related to, all the issues related to sustainability, and it's like a big, thick book. Like
Oh
this,
yeah, I
okay?
believe it.
Solvent bad, CO2 good. That's basically the whole entire conglomeration of it. And so,
All right.
it's pretty good. It's got a lot of stuff in there. But at the end of the day, the other thing that they brought up was that, if you do have like even an ethanol extracted and or a solvent extracted biomass, you really can't compost that in an effective way or use that in like feed.
Yep.
That has a lot of protein in it actually. That stuff does. So, but with CO2, it just vents off and it's perfectly clean.
Right. So again, moving forward, when they start opening the doors for that to use that biomass as feed, I mean, if you're using ethanol, that's going to kind of close you out of a market from extracting as much money as you can out of that commodity. So
Yeah. Plus, some people are saying that you need to, pay to get it manifested because it has organic solvents in it, right?
Yeah.
So, and really, the rules there are really rather loose. Okay.
Yeah.
You have to have a lot of solvent in there, but I know that, like, we got in a bunch of stuff to extract one time, and it had it had hexane in it. It had ethanol in it. Remember that?
I remember. Yes.
And it had acetone in it. I'm like, well, man, these guys are. What they did was they literally they must have taken their flour, filled up a thing with gasoline, dipped it in the gasoline because it had everything in it.
Yeah,
it was crazy.
that was weird. Yeah, don't send people biomass that you use poisons to extract with.
And the other thing is, don't landfill that either. Unless
No.
without a permit, or don't put that in your your pile for
composting. That's typically what most people, I feel like, do. But yeah, you're putting that back into your soil. It's just going to make it harder for that plant to grow.
Right.
I mean,
especially if you have like a denaturant in it. Or something
yes,
like
yes. Denaturants, don't even get me started on those. Why anybody would use something that is not made for
Heptane.
Human consumption and then use it for extraction and sell it in a consumable product.
I don't get it.
You're a bad
I
actor.
don't get it. I mean, what really really is affecting to me is how they produce soy. Okay, we're wondering about what is it seems like there's an upward tick in a prevalence of diagnosed cancers. Okay, and if you look at the number of stuff we do have, is it just the fact that we're diagnosing it more, or is it just the fact that we're kind of eating chemicals like this every day?
Yep.
You know what I mean?
The
And
latter.
we're kind of doing it to ourselves, but why? So why? So we think we can save 3 pennies off on a microgram or something like that?
Yeah.
I mean,
that's
really? Is that it? So I don't know. Hey, look, I mean, hexane is toxic, okay? So you can't have a lot of it in the feed stuff. But look, the FDA says, hey, no problem, 500 parts per million. That's all right.
Yeah.
That's all right. You could have that. Why is that? Oh, because we don't know if it's not safe.
Right.
When did they ever take that stance with anything else? I mean,
Exactly.
let alone hemp, for example. Well, you
Yeah.
can't really have it because we don't know if it's not safe. And
Right,
then there's,
that's-
oh, it's okay if you have 500 parts per million because we don't know it's not safe.
Right.
This is just not.
It seems
you
like
can
a game
There's
sometimes.
one main difference, and that is the Pharmaceutical Manufacturers Association
Yeah.
that are available there, which I think that there's a lot of really great people there. They have a lot of sustainability, mindset and
Yeah.
everything like that. For sure, chemical engineers, they're always looking at that,
Yeah.
and they're looking for, options. So what's the second thing here?
So
Second answer.
for every 1 gram of tincture vape pen containing CO2 oil, 0.24 pounds of CO2 were emitted.
Wow.
So we're talking a 1/4 pound versus 95 pounds for a 1 gram vape cartridge. So that's quite the difference.
It's huge. So 0.24 versus 95 pounds.
Yep.
So think about that next time you take a puff on your pen.
Yeah.
What are you costing the environment by just, So
Right.
besides the fact that you're also getting a higher quality, pen, or you're getting a higher
Yeah.
quality tincture along with the CO2
Yeah.
oils and things like that. So, so now we could probably go into some of the details on that. But before we do that, I'd like to kind of go to the end result.
Oh, yeah.
Which is kind of cool here. That's the most sustainable method. Okay.
Oh, my goodness.
So there are points of argument as to
Always.
as to what you would include and exclude, and so we used an ISO method in our life cycle assessment, is what they call it. So
Yep.
the EPA has produced guidelines to really understand the sustainability of either a process or a chemical process or whatever, and they have a set of things that you need to do, and then the International Standards Organization, ISO, also created a ISO process for that.
All right.
Which is kind of cool.
Yeah, absolutely. I mean,
Because there was a lot of claims that were out there that didn't follow the process
Right.
of really the assessment. Okay?
Yeah.
So I have read the standard. Okay. I'm not certified according to that ISO standard. We haven't done that. If you called them up, it'd probably cost us, 20 grand. Or
Oh,
something
yeah,
like
it's
that.
not-
Oh,
not
we'll
cheap.
certify you to that, no problem. Okay.
Yeah.
But what we did is we read it, and then I followed it, and we followed it, and we did the methodology. So we're using some, standardized methodology that's scientifically sound and all
Yep.
of that. And so here, and what we really looked at was we calculated the carbon footprint. In other words, we looked at the VOC and we converted it to pounds of CO2. We looked at the HAP, we converted it to CO2. We looked at the energy usage and we converted it to CO2. And then we looked at any carbon actual CO2 usage or CO2 generation.
Yep.
We converted it over to CO2. Okay, so. And we did that for CO2 and ethanol for the exact same amount. So we kind of standardized, okay, so for every 2,000 pounds processed, this is what you would get.
Right.
Okay.
Right.
And then we put those processes out by month. Okay, so we started
Man.
to add the cumulative amount
Yep.
of CO2. So here's what we would create in 1 month. And then we go to the second month, and then the third month, and the fourth month, and we just keep adding it up.
Yep.
Okay, now it looks like this CO2 is like 0, but it's not.
Right.
It's not. It's just this is so large that you can't actually see the slope.
Right.
Okay, so it's actually not, whatever. But if you plot this on a logarithmic scale, you can actually see them, but then the scale is logarithmic, and people don't understand logs, so that's why I don't do that.
No, unless we're building a cabin, I don't.
No.
I don't know too much about those.
That's all good. So, so here's the assumptions here with the calculation. We're running 2,000 pounds. We got 10
Yep.
lots. We're gonna switch over 10 lots.
Yep.
We're using the standard, 30 to 35 gallon, ethanol extractor. We're heating
Yep.
it up, and we're evaporating it off.
Yep.
And we're cooling it down, so it's a ethanol,
Cryo-ethanol.
minus 20, I think is what I assume.
Yep.
5% loss to ethanol, and if you put this to 2% or 1%, it doesn't change this slope. that
Doesn't
much.
change it very much, no.
So you guys can argue over that. I don't care. It is what it is,
Yep.
And then 1,500 cycles per month. So, and then we did that for CO2 plus winterization. A lot of people, kind of level the accusation. Oh well, CO2 you have to have winterization anyway, right? So why are you you know, you still have this large carbon footprint? Well, we accounted for that winterization. That
Yeah.
if you wanted to do winterization, you can do subcritical if you want
Yeah.
to, and kind of reduce your winterization.
That's a longer
You know,
process.
it's a
not
longer
as
process.
not as efficient.
But you can still do it, and you can get
Absolutely.
some good terpsichore out of that,
Yep,
and
yep.
you do subcritical, and no problem at all. So anyway, so that's the CO2 plus winterization. So we did account for the amount of ethanol that you would use, but you know, it's not even on the same planet.
We're not losing anything during winterization.
Yeah.
Where you are during extraction.
Right,
So I
right.
mean, that's going to make a difference as well.
Right. So here's a little amount that you might use in winterization, and then you have the whole room here filled up with amount that you'd use in ethanol. Okay, so
Right.
stuff like that. So
Yeah.
those are the assumptions. You can see, you can see you're just generating a lot of CO2.
Yeah.
And so from each month right here, you have a certain amount of output because the CO2 is outputting that amount of oil,
Right.
and then the ethanol is outputting that amount of oil, right? So
Correct.
So that's where I just divided the amount of oil per month
Being
in
produced.
grams by the CO2 amount,
Yeah.
and that's where you get the difference.
Yep.
So that's where you come up with the 95 pounds versus the
Yeah.
quarter pound.
These aren't just numbers Dr. John's making up, I
Yeah,
swear.
we got it all
We
set
got it
up here.
down.
So if you're really interested in a sustainable operation, you guys really should give us a call. I mean, we have the resources. We got the calculators. You know, we can go into more depth about, you know, building sustainability into
Right.
your process. Okay. And things like that. And I have other really good news to tell you. And that is, if you are sustainable, if you do sustainability, you are going to be saving a ton of money.
Yeah.
So
Yeah.
it's not like, oh, what is sustainability
What's it
going
going
to
to
cost
cost?
me?
Yep. 'Cause
Oh, okay. What
that
is it going to cost me? No, it's not actually not going to cost. In fact, you are going to be making bankola.
Yep.
And I'll tell you, one of the main reasons is because this solvent changeover here after each lot is going to cost you a lot of money.
Yep. And that's
Okay.
basically, and do you want to explain what that is a little bit?
Sure. So, okay, if you are GMP, GPP, or EU GMP, doesn't matter. If you're actually in a regulated, if you're not mixing it up in your bathtub type of thing, if you're
Right.
you're actually operating, okay, you're following GMP, or if you're certified GMP, there's a lot of concern over cross contamination between lots.
Yep.
Okay, so a lot of people will follow what's called GMP reuse rules. Okay,
Right.
and those are the following. You know, you can't reuse it again and again and again and again forever.
What?
No.
Oh, man. How am I supposed to save money?
Yeah, exactly. You know, because that you know, as Doug Fryer says, it gets janky.
Yes.
It does get janky. The
Absolutely.
ethanol gets janky. It gets you can tell.
Well, yeah,
Even
I can imagine.
after you rotovap it again and again, you just look at it. And like it's not, you know. And if you tested it for purity, it would not be
have all
you'd
sorts
be
of
able-
different
yeah,
things
have
in there.
stuff in it. So
Yep.
that's why the FDA has really put those rules in. They're really good.
Yeah, absolutely.
And what you need to do is you need to have a reuse method, and then you need to validate that method and
Right.
show that, hey, this is the number of times I can reuse it until it gets janky to the point where we can't use it anymore.
Right.
Okay. In GPP world, up in Canada, for example, a lot of the people who, you know, kind of went into the world saying, okay, hey, we're gonna go ethanol extraction, we're
Yep.
gonna do this, and it's gonna be great. Okay.
Yep.
They found out later on that
It's
hey,
not so great.
they have to change over their solvents.
So
often,
basically
it doesn't-
throwing it out
They're
and-
throwing it out, right?
and have to get
and
new
that's
stuff.
hazardous waste.
Yes, it's not just again going in the
You
landfill.
have to, yeah. Okay, so how? That's another thing. How do you manifest hazardous waste? How do you do it?
But
You put it in a big barrel and send it out with a safety clean, right?
Oh,
Out
right.
the back. What
Yep.
do they do with it?
I guess I never really think about it.
They
'Cause-
incinerate it.
so they just set it on fire.
Well, there's all kinds of methods that they do.
Right,
But
yep.
they basically they feed it into an incinerator, and then usually they use that for electrical generation or whatever.
Okay.
So it's pretty good, but obviously there's CO2 that's
Being
produced
released.
from that.
yes.
Right, so that's
Yep.
the other thing that you really need to think about. Okay, so
Man.
that's what solvent changeover is, and
Okay.
we forgot to talk about that with you know, how ethanol itself is being manifested, right?
Yeah.
I mean, it's a lot.
Yeah, it takes a lot to make that stuff.
I had a conversation this last week with a couple guys that are like, oh yeah, you know, I walked through two or three places, and there's this equipment that's on the market, and you know, they went out of business and everything. We were just wondering, why are they going out of business? And I'm like, well, let me see the equipment. Sure enough, there it is. It's ethanol equipment.
Yeah.
People didn't seem to do the math ahead of time.
They like
bought
that
the
little price
equipment
tag.
because of they like the price
That's
tag.
the bid number one. Yeah.
Yeah, they're
the
like,
price
oh
tag.
well, look, I have to pay double for this other thing. You know, why should I do it, right?
Well, again, they didn't do the math. They didn't check out the calculators to see the operating.
All they had to do was
costs
give us a call. We could have saved them millions of dollars plus a non-bankruptcy, right?
Exactly.
I
Yep,
mean, literally,
it doesn't
they could
take
save
much.
you millions of dollars. So I'm not going to go through all the details right now, but I would like to go over this, and this is why green pays. So this is the lowest cost, most sustainable offering. And interestingly enough, this slope is green. And what that represents is cumulative operating cost as a function of time. Okay, so this is exactly the same methods that we were just using, okay, and that we did to do our CO2 calculations.
Yep.
And then you just add up the costs. And what are the costs? Well, we got solvent loss, number one.
Yep.
Number two, we have hazardous waste disposal.
Right. Yep.
Right. It's going to cost you something. Did you think
Absolutely.
of that? Is that in your business plan?
Right.
Right.
Yep.
In fact, you know, there are people who have been caught, you know, manifesting their hazardous waste in the wrong way, you know, because they're like, oh, what do you mean I have to manifest that, like, $2,000?
I have to pay to get rid of this stuff? Yeah.
Forget it. I'm going to stick it out. I'm going to put it in the back of my truck and go drive around with a cork open.
Right.
I mean, that actually happened.
Yeah.
Okay.
I believe it.
Or just manifesting it by dropping the barrel off in someone else's property.
Fell off the truck. Yeah.
Fell off the truck. Okay. This is bad news. Okay.
Yeah. Don't be a bad actor.
Don't be a bad actor. Yeah. So anyway, so this is the green line here, and that's the cumulative operating cost. So, and then if you take the CO2 calculator and you do the same operating cost, you can see, look, I'm paying a little bit more for
that initial cost.
Yeah, you got a little initial cost, but look at what happens. You get this crossover here. Because the operating cost is so low.
Yep.
The sustainability is so high.
Yep.
And so this is why, you know, people who are in large industrial offices and large industrial engineering firms and large industrial processing, they're all like, okay, well, yeah, if we had a solution, we'd do it. But we don't have a solution, so, well, I guess we'll go with hexane.
Yeah.
Well, yeah, I'll go with
the solution is there. You just have to know where to look.
The funny thing is that, you know, the cannabis industry is not at the soy scale industry. We're not doing 100 tons a day.
No, not quite.
Cannabis industries or the hemp industry is very, very small. It's less than a ton a day. You know, normally in most places, maybe 400 pounds a day. That, you know, even 200 pounds a day might be a really good operation. Okay.
Yeah.
We're not at that scale, so why destroy the environment?
Right.
You know,
for the cost of profits. No.
And then or the cost of profits. Yeah, exactly. So here's some figures for you guys to keep in mind as to why CO2 extraction pays. Okay, number one, 18 times less energy use compared to ethanol.
That just again.
It's not 18%, by the way.
Right.
It's 1,800%. Okay?
Exactly.
It's actually 18 times.
Man.
So 125 times less solvent loss cost.
So again, that's the 4 cents a pound for CO2 versus. 20.
No, this is solvent loss. So like if I lose like 5% to the tailings, or if I lose 5% to the biomass, for example, or 3% or whatever. I did have some solvent loss that I put in there, cost for CO2, because we do winterization. There's a small amount of solvent that you do lose.
Yep.
6x less solvent startup cost. Okay, so if I have a startup, right?
Yep.
And I'm trying to figure out, okay, now I need to go buy enough to get started and to actually use, so I don't have to have it coming in every day.
Right.
Well, typically people get a micro bulk system, or they get a bulk system.
Yep.
And they'll just feed their process using that. And that's really great, because you're talking about 4 to 8 cents a pound.
Yeah.
Would be typical for in bulk purchases.
Right.
You know, but on ethanol side, let's just say you're going to use food grade ethanol, right? Which you should be
It's
using.
the standard.
Not denatured ethanol, but
Food grade is about the lowest of the barrel that you'd want to use.
right. So you got not gasoline. You don't want to use gasoline.
No, please don't.
These chemical companies, they really do have, they kind of get offended by this kind of talk because they're making bank by people, selling people heptane and hexane and
they don't care. Again, it's just profits to them.
Yeah,
and if it's going to save their clients money, they have no problem selling it. You
know, the other thing, a lot of people listen to us talking here and they say, "Oh, you guys are anti-ethanol extraction." We're not. We're not actually.
No.
So we're great fine. If you go ahead, it does have the higher CO2 footprint, and it does cost you more, but there are some instances where you might want to do CO2 versus ethanol or ethanol extraction. No problem. We just say do it the right way,
please.
Make sure you do the manifest. Make sure you use food grade.
Absolutely.
Okay, so solvent startup costs obviously are more expensive with food grade alcohols, right? I mean, it is more expensive.
Right, almost 4 or 5 times expensive.
Yeah, so you can say, oh well, it doesn't cost me that much. I buy it by the tanker truckload, and I'm gonna get a semi truck in here, and it's gonna be in. Okay, that's fine. That's fine. You better watch out what you can actually store on site.
Right.
All the requirements for that. Your fire inspector is going to be
see
like,
how he likes
hey, look
that.
at that. I'm gonna it's like,
right.
Okay, this is a big one. 394 times less cost of solvent reuse and changeover cost.
Man, that's even more than the energy use.
Yeah.
Or the solvent loss cost. I mean, that's just astronomical.
Right. So you got, everything. Like we have on our website, we got all of our competitors on our website all the time.
Yeah. Oh yeah, we see you guys. We know you're
you guys
there.
are all over. It's just like I'll clicking on their stuff, trying to download it and everything. What are they saying about this?
Oh
They're taking notes, going in our
100%,
podcast,
100%.
Okay, let's see what we can rip off from
right.
Dr. John.
How can we make this
today.
ours?
How can we make this ours? That's some good stuff.
Yeah.
Copy paste.
Yeah, that's what it feels like sometimes.
Oh yeah, it is kind of like that, but that's okay. That's what being a leader in the industry
absolutely
means. So,
absolutely.
But this 394x less cost of solvent reuse, and that has to do with solvent reuse and solvent reuse rules.
Yep.
Okay, you say, okay, well, guy, hey, we're gonna use that forever. We don't really care about reuse. We don't care about GMP. We don't care about cross-contamination. We don't care about all that stuff. We're just going to mix it up in our basement. And we're kind of one and done, run and gun.
Yeah.
Run and done, one and done. We're going to leave them.
No long-term growth plans. Yeah.
Just make the buck. There's a lot of that out there, unfortunately.
Absolutely. Not just with hemp, it started happening with Delta 8.
Yeah.
And,
Right.
Yeah, that's a whole nother talk. But
a whole nother talk. Okay, no, we're going to have tons of comments. More about Delta 8. It's the witch's brew.
Oh, yeah. Well.
3x less infrastructure cost. Okay, that has to do with the H4 occupancy, which is hazardous occupancy, versus versus just general industrial occupancy. Yeah, so
it's going to cost a lot more.
A lot more because you have a lot more solvents around. So those are some things that you guys need to think about. So, hey, thanks for joining us. I appreciate your time. Good to have you on here, Jerry.
Yeah, thank you, John, for having me.
Yeah, no problem. And we'll be talking to you guys later. I mean, if you want to learn anything more about, how to make your operation sustainable, you want to understand, hey, I don't really believe these. I'd like to see the calculations. Maybe in the next episode, we'll go through some more of the calculations, and you guys can see what we're talking about there and get some more details on that. A lot of people go, as soon as we add calculations in there. But hey, take our calculator. Go onto our website. We'll put it under the resources page there, and take our quiz.
Sustainability quiz.
We kind of already gave them the answers.
A little bit. Well, first person that sends us something, maybe we'll have something nice. If you live in the U.S.,
exactly.
Hop on there. Let's see what you got.
All right. So thanks and take care. It was a good show.
Awesome.
See you later.
Stay sustainable.
Yep. See you. Bye.